Okay, today's lesson's a little longer, but it's to do with the equation of a line and the gradient. The equation of a line can be written two ways. There is y equals mx plus c. Now m is the gradient, that's the steepness. To find the gradient, you pick two coordinates and find the difference in the x's and divide it by the difference in the y's. The end value, the number on its own, is called the y-intercept. It's where it crosses the y-axis. This equation can also be written like this. Y minus y1 equals mx minus x1. Now, x1 and y1 is just a point on a line. They're just coordinates. So we're going to work through these examples and hopefully this will make sense. Find the gradient joining these 2 points. So the gradient is the difference in y's over the difference in x's. Now it's really important you keep your order correct here. So I will start off with this coordinate here. So minus 1, take away the other y. Now do the x's, starting with this coordinate. Minus x, take away the other x. So I have got minus 3 over minus 10. Two minuses cancel to give you 3 over 10, or 0.3. Now the next one, so we've got the system. You're told, find the value of n if the gradient. So what is the gradient again? The gradient is the difference in y's over difference in x's. So let's look at our coordinates, 3a and 4, n and minus 8. Now, you're told the gradient is the difference in the y's. So start here. So 4 minus 8 over the difference in the x's. 3a minus n. And you're told that equals 2. So tidying this up a little bit. So 4 plus 8 is 12. Now I'm going to bracket this and bring it up to our side in a minute. So my equation now, so I just write up here, is 12 equals, and I'm bringing that bracket over. It's quite complex here. The question says find the value of n. So I want n on its own. So let's see how I'm going to do that. So it's 12 equals, timesing out that wee bracket, 6a minus 2n. I want n on its own. So move this 6a over to the other side. I've got a negative letter, so just change all signs. So it becomes negative 12 plus 6a equals 2n. And just divide everything now by 2 to get n on its own. So I have found the value of n. Don't worry about an a still being in there. That's just starting to work with more complex algebra. That's fine. You can leave it. So you have found an n. Now, example 3. If I go back to the beginning, the first thing I showed you at the top of this was y equals mx plus c. That was the gradient. And this was where it crossed the y-axis, called the y-intercept. Now this question is all about trying to find the gradient and the y-intercept. Now you can look straight in part A and see the gradient is 5 and the y-intercept is 4. In this one here, if you notice, I don't have y equals, I've got 2y. So I've got to do a wee bit of work with that first. So I want y on its own, so it matches up to this. So divide everything by 2. So y equals 4x add 4. Now m, as the gradient, is in front of the x, and the y-intercept is on its own. If you look at part C, it's even more of a mess. I've got 7x minus 2y equals 3. I must have y equals. So I'll bring this 7x over, and it becomes minus 7x. I will change all signs. I will write the x first and then the number at the end. I will divide everything by 2. Now, the gradient is in front of the x, so it's 3.5, and the y-intercept is on its own. And lastly, part D. It's another mess. I must have y equals. So bring this x over as a minus x. Divide everything by 3. That becomes x over 3 or a third x. I like to write it with the x first and the number at the end. The gradient is minus 3 and the y-intercept is 2. Now you're just going to keep working with that. Now, I'm going to bring up two key words here. Parallel means the same gradient. Perpendicular means it meets at right angles. And the way we do that in coordinate geometry is minus 1 over the gradient. Now, so we'll come back to those. So this question says find the equation of a line. So you can either go y equals mx plus c, or y minus the y coordinate equals mx minus the x coordinate. The gradient is 3 in each of these. So 3x plus c, putting the gradient in there. Now this is asking for the y intersection. Now if you look at this graph, not 2, it crosses the y-axis at 2. So you have been told the y-intersection there, so it's quite easy. On this one, just sub in your y-coordinate, sub in your x-coordinate, and tidy up. So either method's fine. Go to this one here. Equation of a line. So y equals mx plus c, or y minus y1 equals mx minus x1. I've got to work out the gradient. I haven't been told the gradient this time. And if you remember the gradient, it's the difference in y's over difference in x's. So looking at this, starting here, 5 minus this y. Start here, 2 minus this x. So 8 over minus 4. My gradient is minus 2. Minus 2x plus c, or use this equation, minus 2x minus x1. This time, you've not been told where it crosses the x-axis, or sorry, the y-axis. So I would strongly recommend you use this formula. This one does get quite complicated. So using this formula, put in either point. I'm going to put in this one here. So y minus the y coordinate, x minus the x coordinate, times out your bracket. Remember, minus 2 is minus 2 is plus 4. And then just tidy it up. 4 add 5 is 9. Next example, find the equation of a line. So y equals mx plus c, or y minus y1 equals mx minus x1. I'm going through this point. It doesn't tell me the y-intercept, so I will use this equation. So going through, y minus 5 equals mx minus minus 1. I'm told in parallel, so it's going to have the same gradient of this. At the minute, I can't figure out this gradient because it's not in the right form. So I need to bring that 3x over. So I have got y equals, and remember the gradient is in front of the x, the gradient is 3. So just over to my wee equation. This line is parallel, so it's going to have the same gradient. So 3x plus 1. Y minus 5 equals 3x plus 3. And bring your minus 5 over as an add. Y equals 3x, add 8. Now, two more questions to go. They are tricky. So I'll take my time to get through these. So it says, find the equation. So y equals mx plus c, or y minus y1 equals mx minus x1. It's looking for the perpendicular. So that's one of those key words. So the perpendicular, we saw over the page there, means it's minus 1 over the gradient. So we need to work out the gradient. Let's see. I've got these 2 points here. So what is my gradient of these 2 points? So remember how to do that. It's the difference in y's over difference in x's. So if you look here, start with this one. 6 minus minus 2, and then do the x's. Minus 1, take away 5. So 8 over minus 6, that cancels down to minus 4 over 3. But yours is perpendicular. So the perpendicular gradient is minus 1 over that. Two minuses give you a plus. Now if you put into your fraction, into your calculator, 1 divided by 4/3, it turns it upside down. So if you remember, dividing by a fraction turns it upside down. So your gradient is 3 over 4. So in my wee equation, I'll use this one. I've got y minus the y coordinate equals my gradient, because it's a perpendicular one, x minus x1. Now there's another very important word here, bisector. Bisector means you're splitting it in half. So you've got these 2 points and you're splitting them in half. Basically you're going through the midpoint. So if you remember how to do the midpoint is the average x, so add them, divide by 2, and add the y's and divide by 2. So your midpoint is 4 over 2, 4 over 2. That's the point you put into here. Now this is a very, very complex question, and if you're not getting that, don't worry too much about it because it is very difficult. I'm just timesing out the bracket here. So y equals 3x over 4. That cancels down to minus 3 over 2 plus 2. And your final answer is 3x over 4 plus a half. I'll just recap over some of those key terms. Equation. We tend to use that one when work gets harder. Perpendicular meant it was minus 1 over the gradient. Worked out the gradient meant minus 1 over it. Bisector meant you were going through the middle. So it was the midpoint of those two. And pulling it all together. So you had the perpendicular gradient. You had the midpoint that the line was going through. And then you just put it into your formula. Now we're finishing off on something really quite simple now, you'll be glad to hear. Draw x equals 2. Now x equals 2 goes through the x-axis at 2. X equals minus 2 goes through the x-axis. And the other ones, y equals 2 goes through the y-axis at 2. And y equals minus 2 goes through the y-axis. So just remember these lines go through the relevant axis. So go through the y-axis. And for these ones, go through the x-axis. Now I'd like you to do exercise B. There's just quite a lot of work in that, but it is important you do work your way through these. I have all the answers done out for you. It is quite a lot. I'll put them all up so you can see them and just try your best.